Hello and welcome to today's video. So for this video we're going to be doing Anime Episode Queue Manager, where we're tasked with creating an anime queue which can add episodes, watch episodes, and get episodes. And all of these operations have to be done in all of one time. Okay, well, taking a look at this problem, it just looks like a simple queue problem where we'll have a queue as an internal data structure, and every single time people pass in the name as a parameter or something of the sort, they want to watch it, we can remove it, or they want to get the queue, we can just use an internal queue data structure and utilize its standard methods. So we can do that really quickly. We'll have an init function. We'll do self.queue is equal to queue first of all, and from collections import deck or DQ. Yeah, so actually we'll make this a deck here, deck. And then for adding an episode, what we can do is we can add, so we'll do q.append the name. For watching the episode, q.pop left. Yeah, we want to pop it from the left if that happens, and then return that. So return q.pop left, and then this one we want to return self.queue. Now, we also want to have like a little check just to make sure that the queue is actually populated, because, well, for the watching episode, because if not, if we try to watch an episode where it isn't populated, we probably want to return an empty string, so instead of returning an error. So we can do if self.queue, if not self-queue, we can return a string, otherwise we pop left. Now, if we take a look at the actual code that's running it itself, well, we start off with initializing an anime queue. We add these episodes 1 and 2. We assert and we get what's in the queue. Now, strange thing is that the queue is supposed to have an root episode 2. Naruto episode 2. Because according to the implementation of these examples here, you can have episode 1, episode 2 of this, and just return episode 2. So this one should be returning episode 2 as well. Not quite sure why it's going to be empty. For this one, you're adding episode 1, and you want to get the queue, and then this one should have One Piece episode 1 as well. And then we get the queue, and then it should return nothing. So if we go ahead and run this, queue.append. Oh, forgot to add a self.queue. Same thing with these ones. So we make this queue. Failed to pass all test cases. Now if we take a look at this, episode 1, episode 2, we add episode 1, we add episode 2, and then we take a look, we watch episode 1. Now this one should return episode 2, and then we add episode 1, and then watching the episode should be episode 2. This should be episode 1. I think actually, we might need to convert this from a queue to a list, because it wants a list as the final answer. Okay, yeah. Test code for Python. Test results good. I'll do a quick explanation of it over here, and I'll just type it out right now. Yeah, I just realized because we're converting it into a list, the get queue is going to be a O of n runtime. So because we're gonna have to convert everything to Q. One way that we can stop this from happening I guess what we could do is we could have a list instead. And we keep track of what's in the list as we go about it. But then that would cause the removing operation of the queue to be O of n because you're removing it from there. I think for now it would be better to use a deck instead of a list because it helps the adding and the watching fun time be better than the grabbing one, which I'm assuming we probably want to use more often, the adding and the watching, because people watch and probably add episodes something more than they would grab one. So I'll go ahead and mention that. Nice. So I'll go ahead and submit this now. Just run this one more time to make sure. There we go. Yep. And then we just submit. Nice. Okay. Well, thank you for watching this video. I guess I need to give a little bit of a preface as to what this is. Datacurve is sort of a platform where you can solve traditional lead code style problems, except you get a little bit of a payout at the end. And people can get a payout pretty much by basically either writing problems or solving other people's problems. And it's really neat how this works. It's a friend of mine who made it, and so far it's been a really nice platform to use. So excited to see where this goes.